Welcome to General Chemistry Lab. My name is Dr. Chris Koenigsman. I'm one of the chemistry professors that teaches general chemistry at Fordham. I'm part of a team of professors that will be teaching the various general chemistry lab sections. We'd like to welcome you to general chemistry this fall, and we're going to be in this video giving you an introduction to the course. So to get started, the first thing we're going to take a look at is the course packet. And the reason why we start with the course packet is because this has all of the information you need in order to do general chemistry lab. So it starts out with a to-do list. And the reason why we start with the to-do list is because there are a few things that you have to take care of before we start general chemistry this fall. So general chemistry lab does not start on the first day of classes. So the first week of classes, you won't be starting with lab. What we do is we start with lecture first. We kind of get everybody settled into classes. We get everybody settled into doing general chemistry. And then after about 2 weeks, I'll give you the exact dates in just a few seconds. In about 2 weeks, we get started with the laboratory itself. So before we start the lab, what you need to do is you need to get a copy of the textbook. So the textbook for General Chemistry Lab is the Pearson Laboratory Experiments bundle. It contains the textbook that you need along with a access card for the mastering course that we use. That's our online homework system. The second thing that you need to do, and this video will help you navigate the syllabus, is you need to look at the syllabus carefully. So the first day of class that you will have an orientation with your section's faculty member, and this is the perfect time to ask them any questions you have about the syllabus. So if there's anything in this video that you're not sure about or that you'd like to ask or get more information about, that first day of class is the perfect time to do that. So the first day of class, your first day of class will be sometime during the week of September 14th to the 18th. And depending on what section you are, you'll meet on each section meets on a different day and time. So at some point during the week of September 14th to the 18th, you'll be meeting with your instructor during your lab's assigned time via either Zoom or Blackboard Collaborate. Another thing you're going to want to do before you come to the first lab is read the first experiment. We are going to be doing a mixture of digital experiments and hands-on experiments, and reading the first experiment will allow you to have the information you need for the first digital experiment so that if you have any questions about it, you can ask your instructor on that first day. That'll be another component of the first meeting. They will be discussing that first lab with you a little bit and kind of giving you an introduction to the course and to digital labs. There's also some assignments that you have to do in Mastering Chemistry. So the first set of assignments are going to be due on Sunday, September 13th at 11:55 p.m. So this is before your first laboratory section will meet. This is due by the Sunday of the week that your first laboratory section will meet. So you actually have to do this before you go to class, your lab class, for the first time. So be cognizant of that and make sure you prepare in advance. The assignments are not that difficult, but they do need to be done in advance. So my suggestion is the week before lab starts, get these done nice and early at some point during the week. You don't have to do it on Sunday. You can do it any day you want as long as it's done before Sunday, September 13th. And there are 3 things you need to do. There's an introduction to mastering, which just gives you a basic lay of the land of how to use the software. There's an assignment that gives you a laboratory introduction. There's a safety video, which we would have during our normal semesters. And some of the things in the safety video will be applicable to the at-home experiments. And then there'll be some other introductory things about significant figures and other parts of the laboratory that are useful for you to get to know before you start. And then every digital experiment has what we call a pre-lab. So you're going to be completing the pre-lab for experiment 1, which is why you need to read the experiment. So before you try to complete the pre-lab, you should read the experiment in the textbook because a lot of the information that you'll need to complete the pre-lab assignment is in the textbook itself. Okay, so one of the major components of this class will be the at-home experiments or the in the dormitory experiments that we'll be doing. And we will be giving each student a laboratory kit. So the laboratory kits will be given out on campus for students that live on campus, or if you live within 30 miles of campus, we expect that you just drive to campus. If you don't plan on coming to campus, we just expect that you come to campus one day to pick up your laboratory kit from our technicians. And you can do this anytime during the weeks of September 14th or the 21st. This might vary a little bit depending on when we get the kits in and they're available and ready to pick up. So just keep your eyes peeled for emails from us, but it'll be somewhere in these 2 weeks that you'll be able to pick up your kit. Now, if you live farther than 30 miles or you cannot come to campus for a documented health reason, we will ship the kit to your home. So that makes it a little easier. Like if you live in Massachusetts, you don't need to come all the way to campus if you're not going to be living on campus. So there will be a survey and more information regarding this during the first week of classes. So when you get to campus or when you start your classes, you will be hearing from the laboratory faculty through Blackboard. We'll be sending out a survey that has some questions in it to help us figure out whether you're going to be picking it up on campus or we'll be shipping it to you and we'll be getting your address. So when you get your kit, you just want to open it up, make sure everything is there. We've created a YouTube video that has me basically unboxing a standard laboratory kit and going through all the components. So you'll want to take a look at that and just make sure that you have everything and that you understand what's in the kit. And then before you start the class, there are a few technical suggestions and FAQs that we've included in this packet. Some of these things I will discuss that are important in this video. Other parts of this are just more for your information and if you run into a problem. So the workflow for General Chemistry Lab is that if you run into a problem, you want to check the course packet first for our technical suggestions. If you can't find the answer in our technical suggestions area, then the next step is to contact your section instructor and they will help you with your question. Now, the thing that we want to stress is that because we'll be online this semester, you have to work on getting your technology sorted out, and you'll have plenty of time to do this. We're going to have a practice quiz where you can optimize these things, but you must optimize your connection because we cannot constantly be giving extra time due to technical issues or slow internet connections. So we give you instructions on how to optimize your internet connection and how to check your internet connection, but that's something that you're going to want to do before your first graded assignments. Okay, so let's take a look at the syllabus. The syllabus basically starts with just a little introduction to the course. And really the most important thing to understand is a couple of terms. So there are going to be some synchronous components. And what synchronous means is that that's when you're going to meet together as a group on Zoom or Blackboard Collaborate. So when you see SYN next to an assignment, that means that everybody is coming together to do it as a group. And then there are going to be other things that are done in what we call an asynchronous format. And this is something that you do on your own schedule. So you can pick any day of the week you'd like as long as it's done before the due date. And you can work on it on your own, or you can work on it with your lab group at a mutually convenient time. Like if you want to get together with some of your lab partners to discuss an asynchronous assignment, that's perfectly fine. And to kind of shed some light, there are going to be a couple of different experiments that we're going to talk about. There's going to be some digital experiments and some home experiments, and we'll make that distinction in just a few seconds. So this is just a layout of the different sections and when they are during the week. And this will help you figure out when you'll be meeting for your synchronous times. So for instance, if you're in section R04 and your professor is Dr. Faruznia, you would be meeting on Monday at 1 p.m. for your synchronous period. And your instructor will have more information for you on what platform they'll be using, whether it's Zoom or Blackboard Collaborate. They'll be sending you the links for those meetings and how they'll be sending you the links and all that stuff. So that'll come from your section instructor. But this gives you an idea of when your section will meet. Okay, now this is the single most important part of the syllabus. This is what tells you when everything is due. So this is the schedule of experiments and quizzes. So let's take a look at a couple of average weeks. So you'll notice that there are 3 weeks of class where we do not have lab. And the reason for this is we want to get you guys settled in and sort of used to the general chemistry lecture. Then we introduce the lab and we sort of bring the lab on board slowly over a couple of weeks to get everybody in sync with all the different components of the class. So let's look at how we read this. So the digital experiments are the first main type of assignment that you'll have in lab. And a digital experiment basically consists of a video that will take you through a pre-lab lecture, the laboratory itself, you'll watch the laboratory take place in front of you, and then I will discuss in those videos how to analyze the data. So it kind of takes you through the entire experiment as though you were inside lab. And these are done asynchronously. So this component of the experiment, you're going to go on Blackboard, and I will show you how to complete a digital experiment later on in this video after we get through the course packet. But so digital experiment 1, and it shows that it's asynchronous. The pre-lab, which is done on mastering, and I'll explain to you mastering later on in this video. The pre-lab is due on Sunday, 9/13. So you may want to add this to your calendar or your book or whatever you have. You might want to write down when all the pre-labs are due. So this is before your first day of class, and then the report is going to be due on Saturday. And you're going to notice that this is how it works. For the digital experiments each week, the pre-lab is due on Sunday. So the Sunday before the week of classes, you'll do your pre-lab. You'll go to your class and meet with your professor. And then on Saturday, after you've met with your professor, then the report and the post-lab are due. And the report is basically just the data sheet that comes along with the lab. And I will show you that when we talk about digital experiments. And the post lab is done in mastering. So again, we will see how to complete a digital experiment, and I will go through the entire process for that. But the more important thing is that you understand at this point that what the due dates are. So on Sunday, you'll be completing the pre-labs. Then on Saturday, you'll be completing the post-lab. And then the whole thing recycles. So with digital experiment 2, after you've submitted digital experiment 1, then the next Sunday you do your pre-lab, and then it goes to the next Saturday. So that's the first line, is the digital experiment. Then the second line is going to be your synchronous stuff. So see, this says meeting 1 course introduction. So this is going to be synchronous. So you meet with your group, and it says at your class time. So you're going to, whatever day that you're assigned, you meet with your group, and your instructor is going to give you an introduction to the course, and you're going to discuss digital experiment 1. And then you'll also notice that there might be some other things on the third line, like for example, lab kit pickup. So this is a week that you'll be wanting to be thinking about picking up the lab kit. Did I hear from my professor about picking up my lab kit, and so on and so forth. Now, digital experiment 2 is going to start, and you're going to see the cycle repeat. So meeting 2, you're going to have a check-in and a little recitation, meaning your professor is going to ask you how things are going. And then that's going to be how the weeks proceed. In the third week, we're going to start with our first home experiment. So the home experiments are done synchronously, meaning you're going to meet with your lab group just like you would during the first 2 meetings, except now you're going to actually do an experiment with your class. And the way this works is during the home experiments, your instructor will put you into a breakout room with 3 or 4 other students. It could be 2, it could be 3, it could be 4 students. It depends on what your instructor is going to do. So you're going to have a lab team, and every student's going to have their own kit. So you're going to have your kit, and you're going to set up the experiment, and so are your colleagues, and you're going to work together as you move through the experiment, each collecting your own data. So everyone's going to have a unique set of data, but you're going to have your team to kind of discuss what's going on, and to if you have a question, or if you need help, or if something doesn't make sense, you can all work together to try to figure it out. So that's what the home experiments are, and I'm going to show you what a home experiment looks like and how to complete it when we get into the Blackboard phase of this video. And then again, at the end of the lab, you'll be finished with your report, and your instructor will just let you know to upload that report to Blackboard. So everything that's handwritten will be uploaded to Blackboard for grading. And then you'll notice this third week, we'll also be having our first quiz, quote unquote. It's a practice quiz. In the evening, we have a window of time from 7 to 10 p.m. where you can, you have your dinner, and then you can kind of sit down and take your quiz in a nice quiet period of time where there's no other classes going on or anything like that. So it just gives you a window where you can open up your quiz. They're a half hour long, and you can work on it. And I will show you a little bit of the practice quiz when we get to Blackboard. So that's how the quizzes work. And you can start the quiz anytime from 7 to 10 p.m. and have the full half hour. The practice quiz is only 15 minutes long, but the regular quizzes are 30 minutes long. And then the semester will continue. You'll see that we continue with the digital experiments, we continue with the home experiments, and then we move through the semester. So on 11/25, we go to Thanksgiving break. There is going to be no labs that day. No labs that week, so just keep that in mind. And then our final exam, when we get back from Thanksgiving break, we're going to have our final on Wednesday during common hours from 2 to 6 p.m. So the digital experiments, we're going to have a series of digital experiments: 1, 2, 3, 4, 5. We skip 6, and then we have 7, 8, 9, 10, and 11. And these are just the names and the topics that are covered in each digital experiment. And then the home experiments are the ones where you actually do your hands-on. So these will be done with your laboratory kit, and you'll be actually obtaining data, doing physical hands-on experiments. And we have a really nice subset of them, everything from determining the density of an egg by neutral buoyancy, all the way up to you do some gas law stuff where you work with antacids to make carbon dioxide. You'll look at the antioxidant power of vitamin C. So those are the home experiments. So what do you need to have in order to complete your experiments? So you're going to need the lab manual and access card. We had this in the to-do list. That's something that you have to buy. The main thing is that you purchase the lab manual and access card in new condition. Don't get anything that's used because it won't work correctly with the mastering. The mastering gets updated every year, and you need to have a new book and new access card in order to use it. So just make sure you get the lab manual and access card from the Rose Hill bookstore in new condition. Okay, so we're going to have the laboratory kit and safety goggles. This is going to be assembled by our laboratory technicians, and we will be getting those out to you either by mail or by having them picked up in class. Now, there is a selection of some household chemicals and items that you will need. I will go over this in a few minutes as we go through the course packet. These are some things that you can find around the house. If you're on campus, you can get these items from local stores, local convenience stores or supermarkets. And you can kind of crowdsource with your colleagues. You know, if one person buys kosher salt, for example, and you get a whole bunch of it, you know, you can share amongst yourselves with social distancing so that, you know, you don't all have to buy it. So you can kind of crowdsource a little bit. And you do need a calculator. The same calculator that you use in lecture, you can use in lab. So when you're completing the hands-on home experiments, you must wear safety glasses. We will provide you with safety glasses in the lab kit. And if you're wearing prescription eyeglasses, you can use those as a substitute for safety glasses. None of the chemicals that we use are particularly dangerous, but a lot of them are not things that you would want to get in your eye. For example, you would not want to get vinegar in your eye. That would burn. So either safety goggles or prescription eyeglasses must be worn at all times during the hands-on experiments. And your instructors will be looking for this, and if they consistently catch you without them on, you will have points taken off of your home experiments. So let's talk a little bit about the digital experiments. I'm going to go through how to complete a digital experiment in a few minutes, so we're not going to go into this in too much detail. But for now, what you should understand is that they're comprised of three parts. There's a pre-lab that we discussed, and this is done in mastering. And this is going to be due on the Sunday before the week of the experiment. Then the digital experiment consists of a video that you watch in YouTube that has all three of the main components of an experiment: the pre-lab lecture, the experiment, and how to analyze the data. And then you complete a data sheet, which is called the lab report, and this is due on the Saturday. So you watch the video, you complete the data sheet, do your calculations, and then you upload this to Blackboard on Saturday. Now, one thing that we like to point out is these data sheets must be submitted as a single PDF. So you can use a variety of free software or a variety of free apps on your iPhone or Android. There's an app called Genius Scan, which works very well. What we don't want is we don't want pictures, multiple pictures of sheets, and we don't want multiple PDFs. We just want one single PDF of all the sheets that are legible. And it's your job to make sure that the PDF files are legible for grading so that we can read them and that, you know, the instructor doesn't have to go hunting you down to try to get a better copy. And then we also have, in addition to the lab reports, we have a few post-lab questions that are done on mastering. And these two components are done at the same time. So these will both be due on Saturday, the post-lab questions and the data sheet. Now, you don't have to do these on Saturday. You can do these any day of the week. You can do them the day of your actual lab, which is what we recommend. And you can submit them at any time as long as it's submitted before the due date. So, you know, it's always best not to have to do things on Saturday because we all want to have our weekend. So if you work ahead and you kind of schedule a day and time to do your asynchronous work, you can have your weekends free and you can know that all of your assignments are completed in advance. You can upload to Blackboard at any time before the due date. And then for the hands-on experiments, these you'll be doing with your instructor, so you'll get a feel for how to do that with them. So how did we grade you? So there are going to be some lab quizzes and exams. There are two short 30-minute quizzes. They're going to cover 4 lab exercises each. So quiz 1 covers experiments 1 through 4 and home experiment 1. And quiz 2 will cover experiments 5 through 9, excluding experiment 6. And then the final exam is cumulative of all of the home experiments and digital experiments. So the lab quizzes and the final are open book, open note. So you can make, review sheets, you can use your textbook. Although we don't recommend that you rely solely on that because these things have a relatively short time window. So you can't be looking things up constantly. So you have to make sure that you really understand what's going on and that you know how to do the calculations, or you will run out of time. And we do not give extra time if you run out because you're constantly searching for things. So they are open note and open book, but you cannot get outside assistance from other students, online sources, or family members. So, you can't be video chatting with your friends when you try to take the quiz. Blackboard has some integrated technologies in place to monitor for this type of cheating. So it kicks back an error if it catches something in your browser or if it catches something going on your computer, and it lets us know. So this is not something to try when you're taking the quizzes. And also they're so short that you're not going to have a lot of time to even try to do that. So the main thing is just have the resources on hand, the open book and the open note, and those should be helpful enough to get through the quiz. So how do we grade you? So the courses are based on the following. So the quizzes are 20%, the final is 25%, the digital experiments are 20%, the home experiments are 15%, and the online exercises are 20%. So what we do is we basically take your grade out of 100 for each one of these different components. We multiply it by 0.2, 0.25, so on and so forth. We add that all up and it gives us what we call a weighted average. So that's the average of all these different components combined. And then what we do is we look at the class average of that weighted average, and we set the class average to a C+. So anybody that's over the class average will get a B or an A. If you do really well above average, then you'll get an A. If you're a little bit above average, you'll be in the Bs. If you're average, you'll be at a C+. If you're below average, you'll be somewhere in the Cs. So that's how it works. For all assignments, numerical answers should be reported with proper significant figures and units, and reactions should be balanced and included phase labels. That will be a key component of all of our grading. So the attendance of synchronous laboratory sessions is mandatory, and we will be taking attendance. So make sure that you attend all of your synchronous laboratory sessions with your instructor. Okay, so now let's just take a look at how to enroll in mastering. So mastering, we're gonna jump onto mastering a little bit later on. This sheet here gives you all the instructions that you need to get into mastering. So as soon as you get your textbook, you can follow these instructions. They're very, very straightforward. This is the course ID that you put in, and you'll be all set up in just a few seconds. You put in your access code, you put in the course ID, and you'll be set up to start going. And you can complete those first 3 assignments right away as soon as you get your textbook. So we included in the course packet a list of what is inside the kit. So we have all the equipment, all the chemicals, and the safety goggles that are in there. So when you get the kit, you're going to want to have this sheet on hand, and you can go through it along with the video that I made of me unboxing a typical kit. And that should at least get you familiarized with everything you have and what's in there. And like I said, this is the list. This is included in the course packet also. This is the list of household items that we don't give you in the kit. So there are a few things that you need. These are all very simple to get if you don't have them already. Coarse kosher salt. This is something that you can buy in a supermarket. Just make sure it's coarse kosher salt. We use this just because it dissolves very, very quickly in water, and it makes the experiments go much faster. You need some bottled water, so you could either get a couple of gallons of Poland Spring or something like that. We don't care what brand it is. The reason why we use bottled water is just so that everyone kind of is starting from the same place, because tap water can vary from area to area. You need an egg, so if you're on campus and you get a pack of 12 eggs, you can share that with a variety. Some of your colleagues can get some of the eggs from you. Distilled white vinegar, baking soda, baking powder, all of these things would be found in a common household. Okay, and now some important technical suggestions. So I'm going to go through this, and the idea here is just that so that you guys can get familiar with some of the things that we want you to do in advance. And these are very simple and straightforward things. So we recommend that when you're doing all of your assignments that you use the Chrome browser on a PC or Mac. And this is because Chrome tends to work the best with Blackboard and mastering. So if you don't have Chrome on your Mac, we recommend that you download it. Most PC users use Chrome. You can also use Firefox if you prefer. That works well. In some cases, you may have to download some things into Firefox to make it work with the Blackboard, but Chrome should work well for everything. We don't suggest that you complete any of the assignments on a mobile device just because this often causes issues with images, videos, and text loading properly. So we recommend a PC or Mac with Chrome. You can use your mobile device for streaming the online content like YouTube, but we recommend a device with larger screens like a tablet or a computer rather than a cell phone just because it's kind of a small screen and you want to really see what's going on. Now, with the quizzes in the final exam, these are timed, and therefore it is really important that you have a stable internet connection during the entire length of the test window. So that we recommend that you check your internet connection and optimize it according to the steps below. And like I said, the laboratory report should be uploaded as a single PDF. So you can use this free app called Genius Scan, and you just download it onto your mobile device, and it uses your phone's camera as a scanner. So just make sure that they're legible before you upload it to Blackboard. So if you're not sure how to optimize your internet connection, you want to make sure that you have at least a minimum of 20 megabytes per second. And you can test using this website called Bandwidth Place. So if you click on this website and then run the test, that will tell you what your upload and download speeds are. If you're running close to or less than 20 Mbps, you're going to want to do something to improve it. So you may want to set your computer up in the same room as the router if you're off campus, or what's even better is to directly connect your computer to the router using an Ethernet cable. That should help to improve it. If you have many family members at home, ask for a 1-hour block during your test window where no one else uses the internet for things like video conferencing, video games, or streaming. This will help to get your computer a little bit more bandwidth. And like I said, if you can plug your computer into the router directly, that will give the best results. Now, if you're on campus, generally speaking, you should have a fairly stable internet connection. It's still worth testing. These directions are more for people who live off campus and may or may not have the best internet connection. And this we're not going to go through in any detail. This is just some tips for technical problems with mastering chemistry. But if you do run into a problem with mastering chemistry, you can come to this part of the course packet, read the instructions. They're asked in they're written in sort of an FAQ form, and this will help you. And then if you can't find your problem in here, you can always email your section instructor. So this is the course packet, and now we're going to go into Blackboard and look at how to complete some of the individual components of the course. In this part of the video, we're going to look at the Blackboard page, a typical Blackboard page for General Chemistry Lab. And this is going to have all the major information and components for the course built into it. So we're going to kind of give an overview of where everything is, and then we're going to go into how to do all of the different components. So how to do a digital experiment, how to do a home experiment, and how to work with mastering. So if you look at the main page, there's going to be an announcement section. We will be sending out all announcements for the course via Blackboard. So you should, keep an eye on your email weekly for course announcements. In this section, the start here in the course information, this is going to contain the video that I'm producing. This is going to contain the video that you're watching right now, the link to that video, along with the course packet, which has all of the information we talked about in this video. And it's going to have a final exam review sheet, which will be more pertinent as we get into the course. So now let's take a look at some of the other aspects of the Blackboard. So we have a link here to the digital experiments, which is going to look like a list. Now, when you open this, you're only going to be able to see one. All of the other experiments will open up from week to week, just so that you don't get overwhelmed in the first couple of days of class. And the same thing for the home experiments. There's going to be a list, and only the first one will be available at the very beginning of class. There's going to be a section for quizzes and the final exam, and we'll come back to that in a second. And we also have a section for lecture videos. So this will depend a little bit on your professor and how they're going to do things. Some professors may put links to their Zoom meetings in here so that you can access your synchronous meetings. Other professors may just generate some YouTube content from the meetings that's edited. And some professors may not put any of the lecture videos in here. It kind of depends on the professor and what they want to accomplish. There is a link to Mastering Chemistry, and this is going to be something that you can use to get out to Mastering Chemistry as you're completing a digital experiment. And then we have a link to the Zoom meeting. So if your professor chooses to use Zoom, you will have a link here that says Zoom meetings. If your professor chooses to use Blackboard Collaborate, there will be a link here that says Blackboard Collaborate. Both softwares are very equivalent, and it just depends on the professor's preference. And then we have the My Grades, and in here, this is where you can access all of your grades for the digital and home experiments. So let's look at how to complete a digital experiment. So when you click in, digital experiment 1 will be available to you, and what you're going to see is you're going to see the following. You're going to see at first, you're going to have an instructions, basically. You're going to have a set of instructions. This is going to walk you through all of the steps. So, and they're pretty straightforward. So it says, read the experiment in the textbook and complete the pre-lab questions on Mastering Chemistry. So that's exactly what you're going to do to start. So as we said in the course packet part, the first thing you want to do is read the experiment. And then when you've read the experiment, that'll give you enough information to go in and start working on the pre-lab questions in Mastering. So at this point, you could just click right on out to Mastering and complete your pre-lab. And this is going to be due on the Sunday. Now, for the first experiment, we have the introduction to the lab kit. So that's in here. You can click to go to YouTube to watch that. If you've already watched it and done your lab kit, that's fine. And then for all experiments, you're going to see the watch the laboratory video. So here's where we have the pre-lab video. And what this is going to look like is when you click on this, it's going to take you over to YouTube.
But what we do need is
you'll see the video, and you'll see me going through the entire experiment, and it'll start with the videos basically start with a pre-lab lecture. So it'll have me talking about density, talking about how we work with density, and then it kind of goes into like a middle part where we actually talk about how we collect the data, and I will show you what we measure the height and width of an acrylic slug, for example. And then finally, at the end, there will be a section on how to do the actual calculations. So I show you how to do the results, how to do the lab report. So that's the video. They range from about 50 minutes to about 25 to 50 minutes, depending on the experiment. Some experiments are a little longer and some experiments are a little shorter. Now, one thing that we have for all experiments, we have these slides that accompany the video. So you can click on these slides. They're in PDF format. You can print them out, or if you prefer, you can, on your tablet, you can annotate them on your tablet, and that way you have exactly what we have in the video to work with. So you can put your notes directly on here as I discuss in the video what's going on. Okay, so that's the laboratory video. You're going to watch that, and that's going to get you ready. Now it says print out and complete the custom data sheet for this experiment. You can also copy the values from the custom data sheet onto the data sheet in your textbook if you don't have a printer. So what we did was we took the data sheets from the experiments and we put the data in for you. So that way there was no miscommunications. This is all discussed inside the video. So, where these values are coming from, and I show you how we get all these different things. But we collate these into the data sheet for you. So you can simply print this out and then complete the remaining part of the data sheet, by hand. And then that is going to be your report that you're going to upload by Saturday. So this is the report when we talk about a report. Now, it's important when you're doing this, all values must have a unit and all values must have the correct number of significant figures. And in some cases, we're going to ask you for just a number. So like in this case, it asks for the radius. You can just put that here. And then in other cases, we're going to ask you to show your work. So wherever it says to show your work, you need to show your complete calculations on the data sheet so that we can grade with partial credit. So that is the report data sheet that you're going to fill out. And then finally, it says scan your data sheet using a PDF app on your phone, so create a single PDF and then upload to Blackboard. So in step 5, there's going to be the experiment 1 data sheet upload. And what you'll notice is that each one of these numbers up here correspond to an item down here. So 4, print out the custom data sheet, is 4 down here on the list. And so when you go to upload, this is very straightforward. Blackboard just has a place where you can do browse. So you browse, you find your PDF, you upload, hit submit, and it will go into be graded to your instructor. And this is going to be due on Saturday at 11:55 p.m. So that's just something to be aware of. So the experiments are the pre-lab is due on Sunday, and the experiments are due on Saturday. So that is how you go about doing a digital experiment. The last component of a digital experiment is completing the post-lab questions on mastering. So again, you can click out to mastering, and this will automatically load mastering. So what we're going to do in the next part of this video is we're going to give an introduction to mastering, since that is an integral part of the digital experiments. So with Mastering Chemistry, once you've logged in for the first time and you follow the directions in the course packet, your Mastering Chemistry is going to look a lot like this. You're going to have a tile that says Chem 1331 Fall 2020. And when you click into that tile, there's going to be a section in here that has assignments. So when you click on the assignments, there's going to be a list of assignments. Not all of these will be available to you all at once. They open up as time goes on. So you're not overwhelmed the first time you look at this. But you can see that the first couple of assignments that are going to be available are going to be the density of the introduction to mastering, the assignment 1 laboratory introduction, and the density of acrylic pre-lab. So let me show you what some of these assignments look like and how you complete it. So the intro to mastering is going to show you how to input all of your answers and how to work with mastering. It's basically mastering's little introduction. They do a much better job than I could of it in a video. So you do that, it takes about 10 minutes, and then you know how to put everything in. Now for the pre-lab questions, these are questions that are designed to sort of bring in some digital content to get you thinking about the experiment that you just read. So for example, we have tutorials that involve intensive properties and extensive properties. So this is something that's going to introduce you to an intensive versus an extensive property using videos and other media. And then also we're going to have simulations for things like density that you'll work with as a tutorial. So the pre-lab is very much a sort of a simulation-driven and question-driven thing to get you thinking about the experiment. And the questions look very much like this. So when you click on a question, they're going to open up and look like this. So some of them are going to be multiple choice, some of them may be input and answer, but and they may have several different parts. So you can see what is the most efficient way to add a powder to a beaker and obtain an accurate weight. So some of these things you'll get from watching the videos and that sort of stuff. So that's the pre-labs, and then the post-labs. So we'll show you experiment 1 post-lab. These are going to be more questions that test your knowledge of, did you understand what happened in the experiment? So we're going to have some questions that are just sort of summative questions that test your knowledge and make sure that you got what we wanted you to get out of the experiment. So as an example, this question asks you to calculate the density of a solid from some information, and then you have to input it with proper units of grams per mil. So this would be an example of a post-lab question. So that's mastering. Each week as you're completing your assignments, you'll be clicking out to mastering to do your pre-lab and post-lab assignments. So the home experiments are going to be somewhat different from the digital experiments, and these are going to basically have a write-up component. So there's going to be a preamble, just like very similar to what you would have in your lab book. These are not in the lab book because we created them this summer. We'll probably add these to the lab book at some point. And at the very end, there's a report sheet, just like the report sheets for the experiments, where you're going to write your data and then scan this as a PDF and upload it. And just like with the digital experiments, there is an upload section here where you can browse and then upload, and then your instructor will get it for grading. So let's take a look at an example of a quiz. So we're going to look at the practice quiz. And the reason why we're going to look at the practice quiz quickly is just because it's only practice. So what we suggest for the practice quiz is this is going to be the exact same time as your regular quizzes, quiz 1 and 2. And it's going to look the same. So it's going to be the same style of questions, and it's going to be very similar. The only thing is it's going to be about half the length. So the practice quiz is only 3 questions and 15 minutes long. The regular quizzes are 6 questions and 30 minutes long. So with the practice quiz, you'll notice that the questions we've designed are all simple to input, right? So they're going to be things like multiple choice or multiple selection. Select all the values that are incorrect. So you would check off more than one thing here. So they're all easy to input question formats, and we do that on purpose because we don't want you guys putting in long and complicated equations and things like that. So, and some of them will have numerical inputs. So we recommend highly that when you do the practice exam, you really study those first two experiments, the experiments that it covers, and that you take it and then you see what you get. And then what you can do is you can contact your section instructor. Let's say, for example, you really thought you studied and you worked hard and you don't get the score that you think you should have gotten, meaning you did much poorly than you thought. That's an indication that your studying is not matching the studying that you need to do in order to be successful. So a big part of the practice quiz is to give you an opportunity to work with your section instructor to figure out how to actually study for the course if you don't already know it. Okay, so the last thing is the Zoom. So when you click into this in the Zoom meeting, depending on what your section instructor does, this will just bring you to the links for the Zoom meetings, and they'll be by date. So you can click in here and you can go directly to your Zoom meeting from here. Some instructors may send the Zoom meeting links via email. It kind of depends, but your Zoom and Blackboard Collaborate will be done through the links on Blackboard. So that is the introduction to the course. That goes over all the main components. I hope this video is helpful. If you have any questions about this video or about the course packet or anything, the first day of class is the time to ask. So, bring your questions with you, and you can go over that with your section instructor. I wish everybody a great semester. I hope you guys really enjoy General Chemistry Lab, and just make sure that you guys start, working hard from the very first digital experiment, because the more you put into this course, the more you will get out of it. So good luck again, and we hope that you all have a great semester.